and welcome to this edition of Group Talk, where you will be learning about securing data and managing certificates. You'll be hearing from Matthias Roeder, Senior Consultant here at GBS.
Welcome everybody. I'm happy to host another Group Talk session for IQ Suite. We have done a couple talking about data loss prevention and email archiving in the past. So these are features of IQ Suite. IQ Suite is the email management suite of group business software. We have been on the market with the Domino implementation for IQ Suite for about 15 years now, probably 16. We were actually one of the first, we were the first company who had a virus scanner for Domino available. At a time where not a lot of people were actually really aware of the threats that were going to hit us a couple of years afterwards. A couple of years later on, we have introduced IQ Suite for Exchange as well. So just to mention, although we do focus on the Domino part in today's session, GBS is providing almost the same solution, a very similar solution for the Exchange environment. It is slightly different because Domino and Exchange are not exactly the same systems, so it starts with the user front end and a couple of features in the background that are slightly different to adjust to the underlying infrastructure. What we can do with IQ Suite is basically we are a server-based environment. We process emails that are routed through a Domino server, and we can manage the configuration from a central point. So just to give you an idea how far you can take that, we have one company who is using IQ Suite in a multinational environment, running multiple servers on multiple continents, sometimes multiple servers in one country. They have language-specific settings. They use IQ Suite from a central administration point and replicate the configuration of IQ Suite throughout their environment. So this is just to give you an idea. We can run IQ Suite in any environment starting with 20 users. I think that is the smallest that we ever had, up to 100,000 installations. The main focus is on the server component, and this is what we're going to talk about today. When we talk about encryption, we typically are faced with a lot of questions that show the complexity of the issue. Email encryption is actually pretty simple. You take a key, you encrypt the data with that key, you send the information to the recipient, and the recipient has a corresponding key, not the same, but one that fits to the one that you used for encryption to decrypt the message. Sounds pretty simple, gets a little bit complex when we talk about email infrastructures. It starts with how do we actually create those keys? Where do we get them from? How do we manage the lifetime of a certificate? How do we provide users with the necessary password for this? So there are a lot of things. How do we distribute a software in our environment so that we can actually use it with an encryption technology? What I'm talking about right now are the first approaches that we had to email encryption, where we were thinking about encrypting email on the client. That is okay if we think about our personal communication, but it is not really the best approach when we talk about huge business environments. Because here we have a couple of issues that we need to deal with. Those are not really connected to encryption, but they are around the issue. It is those things that, how do I prevent that a virus gets encrypted and sent out to a recipient? How do I make sure that an incoming message, although it was encrypted, is not a spam message? How do I provide the integrity of my data? How do I deal with data loss prevention? All of those things are very, very difficult if you try to implement them on the client level. So this is what we do with IQ Suite. We take the email to the server, we process the email on the server, of course, according to the rules and regulations that apply to the business unit where the message came from. So of course we have different rules for different countries that have different legal requirements, for example. So when we think about this, we are able to encrypt messages on the Domino server. Very similar to appliances that are out on the market, but those appliances typically deal with incoming and outgoing messages only. They are not really capable of utilizing the infrastructure that is already there. All of your personal documents, the groups, the managing information that is available within your Domino directory or your Active Directory when we talk about Exchange. What we do with IQ Suite is, because we sit on the Domino server, we can utilize all of that information. We have a couple of customers who actually do not want to use the Domino directory. They have an employee database where they have their organization described, and they want to use this database to make certain decisions about emails. With IQ Suite, we can do that because, as I say, we sit on the Domino server and we process the emails on the Domino server itself. So let's have a quick look what the first approach was. We have created a module within IQ Suite that is called Crypt, and it has been on the market for a number of years now, say 10 years or so, and it was focused on using industry standards, PGP and S-MIME. Those are the two big encryption technologies that you want to use to make the solution independent of the recipient's infrastructure. Because this is one of the big problems that we have in today's email world. When we connected all of our mail infrastructures to the internet, we were suddenly able to communicate with any company in the world, and we did not care about the infrastructure that they are going to use. Due to the underlying protocol of SMTP, this was pretty simple. We translated our messages into SMTP, we sent them to the recipient, and they were able to deal with those messages again. Basically the same happens with PGP and S-MIME, because we are able to encrypt a message using the PGP technology. We can encrypt the message, we can transfer it to the recipient, and we do not care which technology the recipient is using to decrypt it. The only requirement that we have is it must be a PGP encryption technology. Now that is quite simple because we know that the recipient has a PGP software because he sent us a PGP public key that we were using to encrypt the data. If he had used an S-MIME technology, he would have sent us an S-MIME public key, and we would then have used the S-MIME encryption within IQ Suite. And the same story goes on again. We take the public key to encrypt it, we send it to the recipient, and the recipient is able to use his or her private key to decrypt the message and then read the plain text and deal with it. Very simple, very straightforward. once you have overcome the challenge of implementing and getting those certificates. As I say, we do that on the server, so that makes it a little bit easier because you don't need to run around and distribute all of those keys. The disadvantage of a technology like that is that you require the recipient to have a certain software. You do not tell them exactly which software, but it has to be a software that is able either to deal with PGP or NS9. So what we were trying to create afterwards is an independent technology to deal with encryption. Just one word on those of you who have read the words on the slides in the meantime. I was not talking about GNU-PG. Sorry about the typo, that should be a lowercase u in here. GNU-PG is the open source implementation of the technology that is known as PGP. So actually it doesn't matter whether you encrypt with a PGP software and you decrypt with a GNU-PG software. Those are the same because they use exactly the same certificates. It's just the one software costs money, the other software is for free. So let's see what we can do when we look beyond the capabilities of Crypt. This might be an infrastructure that we can use to describe the technologies. Our sender within our company is sending an email to the email server, Domino or Exchange. IQ Suite is installed on this server, and now IQ Suite can make a number of decisions. First decision is we're not going to encrypt the message, so we're going to send it unencrypted to the recipient. That's what we do today with the majority of the messages. They are sent unencrypted over the internet, so the threat behind that is everybody could possibly read that message. Has happened in the past. It is not that simple, but it can be done. And if the advantage is high enough, you will find people who actually take the challenge and try to compromise the infrastructure and read messages as they are processed over the internet. Second possibility, let's assume this is a company and we talk about PGP encryption. PGP is most often used in a company scenario to encrypt the messages from one server to another server. We actually don't tell the users whether this message will be encrypted, and we do not necessarily tell the recipient whether the message was encrypted. It is just to deal with the threat of somebody could read my message while it is transferred. This can very easily be done with PGP, and it is the most cost-effective way. The disadvantage is when we talk about encryption today, we typically mean encryption and digital signatures. So what I would like to know is not only that the message that I am going to send to you has been encrypted and therefore has been transferred without anybody reading it. I would also like to know that nobody could have interfered with the message and that you get a proof that I actually signed that message. A little bit like signing a letter. Yeah? So what I'm going to ask my server to do is I'm going to send the message unencrypted. Virus checking will take place here. Probably a couple of other processes will kick in. Think about email archiving. You want to have archives of unencrypted messages because otherwise you can't read them afterwards.